Nullity and rank of the identity transformation on a vector space of dimension n are. Yes. If the transformation matrix is an identity matrix of order n, then its nullity will be 0, because in identity matrix there is no free variable, no independent variable, only dependent variable. So nullity will be 0 and rank will be n. So next option will be wrong because first one is right. The third one is nullity and rank of the identity transformation on a vector space of dimension n are n. Nullity n and rank 0. No. Wrong. Nullity 0 and rank will be 1. Nullity will be 0 and rank will be n. Nullity and rank have an isomorphism between two vector spaces V and W, both of dimension n are n and 0. डायमेंशन n है तो नलिटी 0 होगी और रैंक n होगा, उल्टा गलत है ये. And next, nullity and rank on isomorphism between two vector spaces will be 0 and n. Yes, this is right. Nullity will be 0 and rank will be n, like this. Nullity आइसोमॉर्फिज्म है. आइसोमॉर्फिज्म का मतलब 1 1 भी है और ऑन टू भी है. 1 1 के लिए nullity 0 होनी चाहिए, so nullity will be 0 or rank will be n because dimension is n. There cannot exist an isomorphism between two vector spaces whose dimension are not the same. आइसोमॉर्फिज्म तभी होता है जब सेम डायमेंशन में लीनियर ट्रांसफॉर्मेशन हो, R2 to R2 या R3 to R3. इफ डायमेंशन सेम नहीं है तो आइसोमॉर्फिज्म नहीं हो सकता है. ये बाय रूल है, इसको चेक भी कर सकते हैं, क्योंकि अगर डायमेंशन सेम नहीं है, सपोज दैट R3 to R2 है, तो जो ट्रांसफॉर्मेशन मैट्रिक्स T होगा उसका जो ऑर्डर होगा वो 2 क्रॉस 3 होगा, यानी कि 2 रो एंड 3 कॉलम. So maximum pivot entry will be 2, so rank will be 2 and maximum, and nullity will be 1. So if nullity is there, then it cannot be 1 1, because for 1 1 nullity should be 0. So rank should be always same, 3 cross 3 or 2 cross 2, because nullity should be 0 and rank should be equal to the codomain. Then only 1 1 and onto condition will be fulfilled and the matrix vector will be isomorphism. So if rank is not same, then there is no exist isomorphism. Okay, next question is, consider the following linear transformation: xyz transfer to x minus z, 2x plus 3y plus z, 3y plus 3z. Which of the matrices corresponding to the given linear transformation T with respect to the standard ordered basis of R3 for both the domain and codomain? So we have to find the matrix for transformation matrix, and the basis are the standard order for both R3 to R3. So first we will write down the value of transformation basis. 1 0 0 will be, according to this representation, will be 1 2 0, and it will be the, we have to write this transformation in the form of basis. So the basis is 1 0 0 and 0 1 0 and 0 0 1. I have written here in the bracket only. You can understand it is the standard basis, so it can be multiplied by 1 plus 2 plus 0, and the next one is 0 3 3, and next one is minus 1 3. So it in this bracket is left, but you can assume that here is the standard basis 1 0 0 0 1 0 and 0 0 1 all are there. So matrices will be 1 2 0 0 3 3 and minus 1 1 3. This matrix will be the transformation matrix. You can get by this. Okay. So the next question, I think we have to perform the row echelon form for the next question. Let's see what is the next is span of S, where what is the kernel of T? Kernel of T is asking kernel of T. So we have to perform the row reduced echelon form, and performing row reduced echelon form, you get this matrix where rank is 2 and nullity is 1. So you can write down this in x minus z is equal to 0 and y plus z is equal to 0. From here x is equal to z and y is equal to minus z. So null space will be look like z minus z and z. Okay, this is will be the null space. The question also is option is there, x z minus z and z. This option is correct, others are wrong. What will be the rank? I have seen the rank is 2 because 2 pivot entry is there. So the next question is choose the correct option. It is a 1 1 or on 2. Let's see. Is contains the nullity 1, so it is not 1 1, and its rank is 2, where the codomain size is R3. So rank of T is not equal to size of codomain, so it is not on 2 also. So it is neither 1 1 nor on 2. Okay. Next question saying that there is a transformation R4 to R4 be a linear transformation. Suppose here is two vectors V1 and V2 are two distinct solution of transformation matrix X is equal to 0. What is the maximum value that rank A can take? Rank A. Rank A, it means the rank of transformation matrix. Okay. So what maximum value can take? So see here. Here is given that the two solution V1 and V2 are the two solution for this matrix. If it is a homogeneous system of matrix, if Ax is equal to 0 has the two type of solution. It is a unique solution or many solution. If it is unique solution, then all vector will be 0, V1, V2 will be 0. This is the unique solution. If it is not there, it means it's many solution. It means that the matrix had any free variable, any at least one free variable is there. If it is a free variable or any independent variable is there, then its nullity should be at least 1. Okay, if v1 v2 are two solution, it means matrix T has some free independent variable, free or independent variable. This means nullity should be at least 1. And what is the rank nullity theorem is? Rank of T and nullity of T is equal to size of U. U to V transformation is there. So rank and nullity addition will be equal to the size of the U, and it is 4, and we find that nullity should be at least 1. So if nullity will be at least 1, then the rank maximum rank can attain 4 minus 1 is equal to 3. Okay, nullity will be 2, then rank will be 2, and if rank nullity will be 3, then rank will be 1. So maximum rank can attain 3 because the nullity should be at least 1. Okay, so come to the next question. To the set of correct option. Any injective linear transformation between any two vector spaces which have the same dimension must be an isomorphism. Saying that if there is a linear transformation between same dimension vector spaces and it is injective or in 1 1, then it must be onto also. Let's check it. If it is R3 to R3 U to V transformation, so as per the rank nullity theorem, rank of T plus nullity of T is equal to size of U. And if it is 1 1, then nullity of T is 0. It means rank of T is equal to size of U. But we can see that rank of T is equal to size of U. rank of T is also equal to dimension of V. Rank of T also is equal to dimension of V. So it's become onto also. So it is a isomorphism. Understand? For onto, the rank of T should be equal to dimension of V. And here see in one case the rank of T is equal to dimension of U. So dimension of U is equal to dimension of V. So if it is same dimension and one, then it will be onto also, then it will be isomorphism. And it's a reverse also possible. Any surjective linear transformation between any two vector spaces which have the same dimension must be an isomorphism. If it is an onto relation between the same dimension, then it is 1 also. It will be isomorphism. Okay. And there does not exist any surjective linear transformation from R2 to R3. R2 to R3 surjective linear transformation not possible, because if the R2 to R3 is a transformation, then the transformation matrix will be 3 cross 2, and 3 cross 2 matrix contain the rank size of maximum 2, because maximum 2 pivot entry is possible. So rank of T maximum should be 2, and for onto condition the rank of T should be equal to the dimension of V and R3. It is R3, so R3 to R2 to R3 surjective transformation not possible. Rank of T is equal to maximum 2, because maximum 2 pivot, so will be 2 is not equal to 3. So surjective transformation from R2 to R3 not possible. Okay. Next is an injective linear transformation as follows. R3 to R3, there is an injective linear transformation. So which of the following can be possible definition of T? So let's check. From R3 to R3, there is a injective linear transformation. Okay. So here is a x, y, z, three variable dimension of 3, and here is a y, x, x plus y. Here its dimension is 2. So from 3 dimension to 2 dimension, injective 1 linear transformation cannot be possible. So first option is wrong. You can see easily, because here dimension 3 and dimension 2, the 3 dimension to 2 dimension, the 1 transformation cannot be possible. Okay. The next one is 3 dimension, and it is also 3 dimension. We will to check further also. Third one is also, and a fourth, x, y, z is equal to y, x plus y, and x plus y plus z. Okay. So you can check by this transformation formula also it is satisfying or not, and you can find these two are fulfilling this formula, and this one is not fulfilling, because the x, y, z first should be y. See here, x, y, z first should be y, then it is saying that second will be x plus y. X plus y will be 1, but here is 0. So this option is also wrong. By this you can check through this also. Let's check these two options. So for 1 transformation, the nullity should be 0. Nullity should be 0. So we have to form a matrix, first form a basis of this transformation and check the nullity. So let's second one. First the basis, first we have to put the value of x1 rest 0, then y1 rest 0, then z1 rest 0, and find its basis. The first one will be if we'll put x is equal to 1 rest 0, will be 0, 1 and 1. and if y is 1, then it will be 1 comma 0 comma 1, and the third one will be, if we put z is equal to 1, then it will be 1 comma 2 comma 3. So put it in a matrix form and apply row reduction check. So it will be 0 1 1 1 0 1 1 2 3. So what will be, if we minus from R1 R3 to R1, and what we will get, it will become 0, it will become 2, so 102 and 102. Then further, if we apply this R3 minus R2, we will get 0 1 1 and 102, and it will be 0 0 0. So you can see here 2 pivot entry only possible, यानी कि दो rank will be 2 and nullity will be 1. So nullity is there, so it cannot be 1 1. Okay, cannot be 1 1. So let's check the third option. For 1 1 injective, nullity should be 0. So let's check third one. If we put x is equal to 1, then it will become the 0 1 and 1, then will become 0 1. First y, let's put the y is equal to 1, and 1 0 1 1 0 1. If then z is equal to 1 1 2 4 1 2 4. Write down in a matrix form. Will be same, 0 1 1, फिर 0 1 1, and फिर 1 0 1, then 1 2 4. Let's minus R3 from R3 and R3 minus R2 will be 0 to 1, it will be minus R2 will be 2. Then perform R3 minus R1 will be 0, this will be 1. And you can solve, you can see this, sorry, 1, there will be 1. You can see there is a 3 pivot entry. You can solve further, double multiply here, it will be 0, and double if here minus reduce here from, it will be 0, and minus from R1 it will be also 0. So the pivot entry will be 3. So here is a nullity 0. So in this option this will be correct, because nullity is 0 and a 1 1 transformation is possible. Oh, the big question. Here it is written that a matrix 2 cross 2 2 cross 2 linear transformation such that it is equal to PA, where the P is a matrix ABCD and the beta is the basis 1 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 1. When ordered basis are 2 cross 2, which of the following matrices represent the matrix corresponding to the linear transformation T with respect to the beta for both domain and codomain. Okay, so let's one basis and see its transformation and how it can be represented by the ordered basis form. So first we will take the first matrix 1 0 0, and according to this transformation representation, it will be P cross A. So P will be ABCD, and A is the matrix 1 0 0. If we multiply this, it will become A 0 C 0, and if we will write down this to its basis form, it will be A multiply 1 0 0 0 plus 0 multiply 1 0 0 1 0 0 plus C multiply 0 0 1 0 plus 0 multiply 0 0 0 1. Like this you have to do for all 4 bases. You have to do multiply with P matrix, will become 0A 0C, and write down in the other ordered basis form, the form of ordered basis. Then here is I have write down the blank matrices. You can assume that it is a order matrices 1 0 0 0 and 0 1 0 0 form, and the coefficient what you will get, write down the coefficient in the matrix form, and T will be A0 C0 A0 C0, second 0A 0C, third one be B0 D0, and फिर 0B 0D. This is the correct answer. Okay. Next question is, choose the set of correct options. There exists a linear transformation from R2 to R2 such that image T is equal to kernel T. Yes, it is order size of 2, so it can be one image and one kernel, like 1001. Here is a 1 is image size is 1, rank is 1, and kernel is 1. So it is possible. But if transformation size is R3 to R3, then it is not possible, because image plus kernel should be 3. So if it is equal, then it should be 1.5 and 1.5. That is not possible, because the rank and nullity should be always in numerical value, natural value. Sorry, it is not possible. The next is V to V a linear transformation, and V1 V2 belongs to V are linearly independent. Then transformation of V1 and transformation of V2 are also linearly independent. It is not necessary, because if you multiply the any vector V with a scalar 0, it will become 0, and if V2, then it also will be 0. So if V1 and V2 are independent, then its transformation should be dependent or independent also. It is not necessary to be independent. But if its transformation independent, then the vector will be independent. V1 and V2 will be independent, because from 0 vector you cannot derive the two independent vectors. So in case of 0 only, the vector can be dependent. So if the transformation vectors are independent, then the original vector is also independent. Option is right. But if original vector is independent, then transformation vector may not be, or may be independent. This is the last question. Okay. Okay. Thank you.